Let us now look into more details as to how to represent digital signals. Let's take the same case where we have a signal which is ranging from 0 volts to 5 volts. Previously, I said that anything which falls in between 0 volts to 2.5 volts, I'm going to treat it as level 0, and any voltage which falls between, or any value which falls between 2.5 volts and 5 volts, I'm going to treat it as level 1. Now, to represent this in a digital system, we use the concept of switches. So, with one switch, I can represent two levels. I'm going to say that level 0 is nothing but a switch in off position, and a level 1 switch, and level 1 is a switch is in on position. So a switch in off position is nothing but a 0, and a switch in on position is nothing but a 1. So this is the 0 and the 1 that you see in computers. That's the binary representation. So a 0 indicates that the switch is off and 1 indicates that the switch is on. So if my switch is off, that means that my voltage is in between 0 and 2.5 volts. And if my switch is on, it means that my voltage is in between 2.5 volts and 5 volts. Now, this compromises accuracy because you are not able to fully utilize the range of the analog voltage, that is 0 volts all the way up to 5 volts. You're having a very big gap. So there's a 2.5 volt gap between 0 and 2.5. So if you want more precision, what you want to do is, you want to use more number of levels. So for example, if I want to divide this into 4 levels, I can have 0 to 1.25 volts, that's level 0, 1.25 to 2.5 volts, that's level 1, 2.5 volts to 3.75 volts, that's level 2. We have already seen this before. 3.75 volts to 5 volts, that's level 3. Now, with one switch, you can represent only 2 levels. Now, if you want to represent more number of levels, you need more switches. So in this case, I'm going to use 2 switches, switch 0 and switch 1. So level 0 indicates that both my switches are off. Level 1 indicates that switch 0 is off but switch 1 is on. Level 2 is switch 0 is on but switch 1 is off. And level 3 is both my switches are on. Now, as you can see, if you have more number of levels, let's say you have 8 levels, then you need 3 switches. Basically, if you have n switches, you can represent 2 power n levels. And this is how modern digital systems are designed. It's all based on switches. And to construct switches from a hardware perspective, we use something known as transistors. You will study this in more detail when you deal with electronics 1 and 2, but transistors are the most basic elements in a digital system.